Welcome to this video going through the entropy pooling intuition. This is a request that I have received from readers of the Portfolio Construction and Risk Management book, where they have told me that they need to be able to explain the method in an intuitive way to their colleagues and other non-technical people. So this is what this video will do. So since most people are familiar with the Black-Litterman model, you can think about entropy pooling as a theoretically sound views and stress testing method similar to Black-Litterman, but just for fully general distributions. So at the core, entropy pooling is centered around a Monte Carlo simulation that we collect into a matrix called R. So here along the columns you will have your returns and risk factors. Along the rows you will have joint scenarios for these return and risk factors, and for each of these joint scenarios you can assign a scenario probability that we collect into the prior probability vector called P. If we then want to implement views or do stress testing, we do it by adjusting these scenario probabilities into the posterior probability vector that we call Q. And basically the way that we do this adjustment is by solving this relative entropy minimization problem subject to linear constraints on the scenario probabilities. So this is what you see here, that you have these matrices which can be functions of this Monte Carlo simulation. So basically in the most fundamental case we just have a view on the mean of some risk factor asset I. So in that case we would just take one of the columns, transpose it, and then multiply it with these scenario probabilities and require that it is equal to some value. So this is the essence of how you implement entropy pooling views. Of course, since these X elements represent scenario probabilities, we must require that they are positive and that they sum to 1. So they will automatically be positive for the entropy pooling problem, but the requirement that the sum to 1 must be implemented in this equality constraints matrix A and vector B. Alright, so then there's this question, why do we minimize the relative entropy, which is also known as the KL divergence? And the short answer is because it has really good properties for our updating problem, similar to the mean squared error having really good properties for linear regression. But that of course does not give much intuition. So basically you can think about entropy pooling helping us update the prior distribution into the posterior that agrees with the views that we have, and predict what will happen to the other assets in a way that does not introduce a lot of spurious structure. So basically one example of spurious structure could be that we have a view that the expected return of an asset should be 10%, and then we have one scenario where this asset has exactly 10% return, and then you just assign all the probability to this one scenario and then have degenerate posterior distributions, which of course in reality we do not believe in. So entropy pooling respects the dependencies that you have in your prior simulation. And here you have an example on the right where we have implemented a view and introduced more risk in the left tails of developed market equities. And then entropy pooling tells us that if we are to respect the dependencies that are in this prior simulation, we would also introduce some more mass into the left tail of corporate high yield. So this is one of the ways that entropy pooling will help us to really stress test very large simulations in a consistent way. Another interesting feature is also that it helps us get the P&L of the derivatives positions automatically satisfied. So it's just as easy to stress test a portfolio containing, let's say, S&P 500 or a portfolio containing S&P 500 and then thousands of derivatives written on S&P 500. Entropy pooling will just give us the results in a correct way, and we don't need to do any repricing. So hopefully by now you see that entropy pooling is so much more than Black-Litterman because it works for fully general distributions. If you for some reason want to use the Kabem prior, well, you can still do it with entropy pooling, but then you have this theoretically sound and nice update. So there are lots more elements to entropy pooling with view confidences and how you implement views in other ways. For example, CVAR and how you get the most performance from using it in a sequential way and do ranking views and all of that. If you want to learn about that, then the best place that you can do it is in the Portfolio Construction Risk Management book, where basically in chapter 5 I've collected everything I know about entropy pooling. I have written it in a consistent notation throughout the chapter, so it makes it easy for you to understand. So basically, no matter how much you end up contributing to this crowdfunding of the book, I'm sure that the time that you save will pay it back many times compared to you trying to learn these things on your own by reading different articles and watching videos and things like that. But of course, there are other entropy pooling resources that I've shared previously. So first of all, I have this video on entropy pooling that uses the fortitudo.tech Python package. I also have a video that uses entropy pooling in a sequential way with S&P 500 and stocks 50 data, just to show you how you get better performance by using it sequentially. And then finally, of course, there's this documentation of the sequential method. But again, in the book, it's given with much more details. It's given with intuition for how you should think about these sequential algorithms and why they're expected to work. So then we also have this causal and predictive framework where you combine Bayesian networks with entropy pooling, and you can do some really interesting causal and predictive views and stress testing. There's a video walkthrough here, and you can then find the documentation of the framework in this article. And as I mentioned before, when you want to do optimization with derivatives, then entropy pooling also helps us a lot. So here in this video and the following article, you will see how you can introduce parameter uncertainty into the underlying and risk factors, and then use entropy pooling to get consistent derivatives P&L when you do resample portfolio optimization. So to summarize, entropy pooling is a generalization of the Black-Litterman model, but it can do so much more, and it works for fully general distributions. If you want to really explore it, then the best way that you can do it is by reading this Portfolio Construction and Risk Management book. And after reading it, if you still feel there is something is missing, then please let me know, so then I will be able to add it in the same way that I did for the intuition of the method here.